Hi everyone, hope you are doing well. So today we'll discuss about this question which is 3918 and it is question number 2 from contest 500 which was the last contest. So this question is easy to medium type question, easy to medium type question, and question is description is very easy. Like you have a number like n equals to 13 and you have to just reverse that number, so it will become 31 reverse of n, and you have to add all those prime numbers which is between 13 and 31. You just have to add it, so you will get the answer 131. So let's see the brute force approach, how we'll approach it. So at first left equals to mean of n and reverse of n, max equals to n of reverse of n, because if number is like here the example, like if number is 10 and if we reverse it, it will become 0. So here right should be 10 and left should be 1. That's why we take minimum and maximum, and then we'll go for one by one, that if every number we'll check it that if it is prime or not. If it is prime, we just add it. So here it will check the it is prime or not. So now what is the time complexity for this one? It is order of right minus left, and for this one, for this function, it will go for up to root of right. Okay, so what will be the total complexity? We can say it like, for worst case it is n into root under n, so it will become order of 1 plus 1, order of, it will become n 1 plus 1 by 2, and it will become n of 1.5. So this is the brute force approach. Then we'll see the optimized approach, where we'll use some algorithm, some vector store, where we store the values, and then we will solve this question. For optimized approach, we will use for optimized approach, we will use this algorithm, sleeve of Eratosthenes. So for optimized approach, we will use this algorithm, sleeve of Eratosthenes. Maybe I am not able to pronounce correctly. So this is the algorithm we will use. So what we will do? So what was the problem here? Here the problem is that for each number we are checking it that it is prime or not, and it will taking order of root n, and if we can decrease it with order of 1, then it will can be optimized. Even though there is only the constraint is very low, 1000, with this algorithm also it can be pass all the test cases. But we will see this optimized approach, like how we will do it. So what was the problem? Like here we number that, let's say left equals to n and right equals to reverse of n. So if we do something like that, that we store a vector like this one, we store a vector, and if we store the all the values also, like if it is prime or not in a vector, then whenever we check any value, let's say the value is I, and if we check in order of 1 from this vector that if it is prime or not, let's say it is x, it is x plus 1, x plus 1, so x plus 1. So if we check it that if it is 0, then it is not prime. If it is 1, then it is prime. So if we check it in that way in order of 1, then it will be optimized approach. Then our whole algorithm is run in order of 1. So how we will do it? So at first we have to store the vector. Let's say vec, it will the size of 0 to 1001, let's say, because the constant is 1000, so that's why we take this. And let's say we store all the values as 1 at the beginning. Let's say all the values is 1. Then what we'll do, then we will check that if every value is check for every value is prime or not. So how we'll do it? So this is the algorithm of sleeve of Eratosthenes. So we will go in that way. So for I equals to, I obviously will start from 2 because 0 and 1 is not prime. I start from 2 and it will go up to 1000. And for, and in the inside we will write in that way, if vec of I double equals to 1, then we will change it. Like for I equals, for let's say j will start from where? I into 2, because let's say here I have a vector like this one, 0 1, and let's say here another vector, it is 2, here it is 3, here it is 4, let's say here it is 5. So if we start like from 2, obviously it is a prime number, it is a prime number. So if it is start from 2, it is a prime, or let's say 3. So we have to check it from into 2, like it is start from into 2. Like if it is 1, then we will make this one is a 0. So it will go up to how much? It will go up to 1000. And how the j will increase? J will increase in that way, like plus of I. So here it is like 2. So at first we have to make it as a 1. Then 4, it's mean 2 into 2, so it will become 4. Then 2 into 3, it will become 6. So here this thing is doing that. Like at first it is 2, then it is 2 plus 2, then it is 2 plus 2 plus 2, then it is 2 plus 2 plus 2 plus 2. So here it is solve that problem in that way. So then we will go for vec of j equals to 0. So this will make our array, and then the third step will be, what we have to do? Third step is just we have to make the reverse. Like let's say reverse val equals to rev of n. So we'll get the reverse value. Then we just have to check it that if it is prime or not. So let's say I equals to mean of, so let's say not I, let's say it is left equals to mean of n and rev, and right equals to max of n and rev. And then what we have to do, let's say we will start from left and then we will go till right, and we have to check it simply, like if, so let's say it is start from left and it will go up to right, and just we have to check it. If wake of I double equals to 1, then we just add this one, answer plus I, answer plus I, then we will just return the answer. So in that way we will solve that problem. So this is the algorithm. Like at first we have to store the vectors, then we have to make the array by use that algorithm, sleeve algorithm. Then we just have to reverse it, then we will start from left and go up to right, and for each value we will check at vector that if it is prime or not. If it is prime, we just need to add it. So algorithm, so let's say vector int, and let's say it is vec, and it will start from, it will the size of 1001, and let's say all the values is 1, and then vec of 1 equals to 0, and vec of 0 is also, vec of 0 is also 0. It is not needed, but for safe it will make the algorithm more safer. For int I equals to 2 and I go up to 1001, sorry, 1 less than 1001, so it will go up to 1000, then we'll go for this. And if wake of I double equals to 1, then we'll just have to int I equals to j in, sorry, int j equals to I into 2, and j less than 1001, and j here previously we mentioned it, that how we'll go for that, this is I, and then we'll go wake of j equals to 0, then this is make our array, and then we'll go for int val equals to n, and let's say int rev of val, let's say it is 0, and we have to reverse the number, so let's say it is while val greater than 0, till then we'll go int digit equals to val modulo 10, and val equals to val divided by 10, and rev of val double equals to rev, sorry, equals to rev into rev val into 10 plus digit. So in that way we'll make that number reverse val, and then we'll go for int I equals to mean of n comma reval, and let's say int end equals to, instead of I, let's say make it as, so here at the algorithm we we did left and right, so here also we'll go right like that, RIGHT, right. So it will go max n comma reval. So then we have to check it, just int answer equals to 0 for int, let's say it is right at, it is right go up to end, and let's say left plus plus, and we have to check it like a wake of left double equals to 1, then we just have to add the answer, and just it's solved, return answer. Let's say we just check it, so here the semicolon, again we have to check right, and sorry, it is right, and now let's check, sorry, it is left, and then answer left, so it is passed all 3 test cases, and let's say submit it. So it is passed all the test cases, and in that way we will solve that algorithm. So what will be the time complexity? Then we have to check it. So time complexity, so for making this array, it will for making this array we traverse whole array, so it will go order of, let's say 1, or we can say order of 1000, so order of 1000, and for make it reverse, it will go up to order of number of digits, and for this one we just have to go left to right, and we just have to check it, let's say it is order of 1. So for worst case we can say it is order of n, and for the space complexity we took this size 0 to 1001, so we took 1000 size, so for space complexity it is also order of n, so this is time complexity, and this one is space complexity. So in that way we'll solve this algorithm. Hope you are able to get